Right. Good afternoon again. As I said earlier, I see guys is still coming in, but we cannot wait. Let we start. I will first share my screen to you guys. Can every one of you see this? Can see my screen? Everyone? Can you see my screen?
Yes, sir.
Okay, thank you. Right, that is Strength of Materials 1. You was previously with Professor Desai. He finished the first part. Myself have only 3 chapters with your guys. That was what we it is temperature, energy, and also then second moment of area. That is what I will do with you, only for 3 chapters. Right, I think any one of you know me by this time. I'm Dr. Bieneke, and hopefully I can help you that you understand this part. And lucky for your guys, you are mechatronics students, and you will not continue with the strength of materials in the future. But people still, this part is very important because you will use this also in the industry a lot. All right, our classes is still at this stage still online till there is other decision by the top management of a university. That is on a Wednesday 1 o'clock, and on a Thursday tomorrow morning 8 o'clock. Please, people, I will try my best to be on time. That's why I want you also to be on time. Then I have also consultation times. Please, if you want to see me face to face, you can make an appointment with me, or otherwise you can inform me, and then we can be also online have a discussion if you want to. My consultation times is on a Tuesday from 1 till 3, and a Wednesday 9:30 till 12. But people, I'm always anytime available for you guys. If you want to talk to me, please send me a mail, and then we can talk also. The other thing what I'm also doing is if you are doing some problems and you have can't get the right answer, you're also willing to send me email me your solution, and I can look into it for you and indicate where is your mistake. All right. There's also some very important dates. You must have a semester test with me that we will discuss later when will be the test before the exam, because you must get for yourself a predicate. Then I have already uploaded for you assignment. You know who is the student assistant. He have helped you with the practical part. The D date for the assignment is the 28th of April. I think that is a week or two from now. And people try to hand it in before 8 o'clock that morning. I will not accept any late ones. You can bring it to my office. A hard copy if you want to, but otherwise you can directly mail it to the student assistant, or you can mail it to me, and I will forward it to a student assistant also. But please, people, when you are doing it, I want it type. That's the first thing what is very important. Then you can work in groups. Maximum what I said to you on the announcement on D2L, that maximum 4. It means you hand in only one report, not 4 different reports. You hand in one report with all 4 students' names on the report. And people, please, do not come later to me and say, but this guy was also part of our reports, but I missed his name. That will not help. If you hand in the report and there's only 3 names, that's the 3 guys who will get the marks. That is very, very important to make sure. Please, people, you will see there is marks also for reference. And check, if a mark say 3 marks for reference, it means I need 3 books what you have used, what I want to see. And do not only tell me I use internet or Google or something like that. That's not good enough. I want to see which textbooks that you use to come to the answers. All right. And you're not allowed to use your ebook what you are working out now. you must use other books out of the library. Or please, that is very, very important. Then some rules here. The classes will be online. I will try and start on time. People, you will see there. Also, I create a link for you under my name for each day. Not only one link for the rest of the time, because I try, but I still struggle. I will find out how to do it. Sometimes the recordings, it looks like for me, it's too big. I struggle to upload the recordings, but I want to put the recordings also there for you. Important is try to attend the classes. That is very important. Your test will be face-to-face on campus, that one test. But I must also have another mark for you on small class tests. That means when we have finished a chapter, we will start with the temperature one. When I have finished the temperature one, I will have an online test with you. You will not use the app. You will not use anything. I will show you that on D2L, and then I will give you a certain time when you must email it to me. That's why it's important. If you miss that day the class, and I will not tell you when is that test. If you miss the class that day, it means you have 0 for the test, and there's no that you can have a second chance. There will be no second chance for you. If you miss it, you miss it, because you must attend every day for classes, every time. Right. Then, please, what we already say, 100% class attendance is important. All the lecture slides, what I will use is on D2L. Please, people, work through it before you came to class. I hope you have already worked through the first pair of slides for today. Then the assignment, I already talked about the assignment, is there. And then, people, you will see I have also uploaded for you tutorials. These are the ones what we will work with when we have done problems. I have looked into your ebook or the Wiley Plus book, and there's also ones what I want to do. But there's also other problems what coming out of old exam question papers, out of other books. And listen carefully to me. If you can do all that problems, everyone, then I guarantee you these 3 chapters in the final exam, the end of the semester, you will get 100% correct. Because in the tutorials, I try to put there for you all the ways, the type of questions, what I can ask you in these 3 chapters. But sometimes people do not open the tutorials. Please go there and look into it. And the other thing what's important is, on my D2L is there for you a formula sheet, or maybe you have already a formula sheet, what you get from your semester test with Prof. Desai. People, keep that formula sheet next to you when you are working out the problems. Because that is the formula sheet, what you will get in the exam. I have set up your exam question paper. I can guarantee you that is the same formula sheet what you will get in the exam. But you directly know where is the formulas when you start looking for it. Right, that is important. The tutorials is very, very important. I will work strictly to that tutorials. And what I have tried there is, I have in all 3 chapters, I have put only there for you 10 problems. That means for me, that you work out only 30 problems. If you can do all that 30 problems, I guarantee you, you will pass. I do not say that for problems in the exam, but I guarantee you, you will pass that 3 chapters of my part of this subject. It's important to do that problems. Right. Okay, you have now the Wiley Plus book, what is online. I think everyone know how it works and things. Dr. Desai already, Prof. Desai already indicated to you how it works. You know what to do about the books. Other book what you can use, but the old book what we have used is the Droschky one. If you have, maybe you can get one, you can work through that book. Also, there's another book, a Gare book. There's a lot of books what you can work with. All right. But overall, the thing is that the main thing here for you is to understand the principles of strength of materials and then also to apply it in the problems, and then some of that problems will you see again in the industry. All right, then by the assessment, you know by this time you will get the predicate mark. If predicate is 50, exam is 50. You can see, check in the study guide how we will come up to your predicate mark. In my case, you will see there's a mark for assignment, there's a mark for a type of a small class test, and then for your semester test. That is important. That. And people, important is you must have a minimum of 40% on your predicate before you allowed to the exam. A 39 is not 40. I hope it's clear today. It's not 40. That means do not come to me and say, but I need only 1 mark. It's not only 1 mark. Because of the weights between me and Prof. Desai, sometimes it's about, you need about 5 to 6 marks to get that 1%. It's not a mark, it's 1%. And people, if you have a 39, we will not change it to 40. That's why work hard and get good marks on the end of the day. All right. The last part from I said, if you attend classes, you take the notes, you do what I ask you to do, you done the assignment, you work through the tutorials, and you have already studied ahead of time, then I think you will get good marks in those 3 chapters, what I'm doing with your guys. All right, that is this part. Is there any questions at this stage? I see we're now about 29 students. And one thing what I understand from other lecturers, I talk to other lecturers in other subjects as well, I understand you are a lazy group and do not want to work, do not ask questions. I hope it's not the case here. I hope you will ask questions, because people remember one thing, there's never ever a bad question, or some guys say a stupid question. There is not. You want to know something, then I can guarantee you other guy have the same question. But please, people, do not think any question is a bad question. Ask your questions, and I'm here to explain to you. If you do not understand anything, you're welcome to make an appointment with me and come to my office when you can sit face to face. But I'm here to help you to understand these 3 chapters, because I want you to get full marks in the exam for those 3 chapters. And you can get it if you do what you're supposed to do and you work through that problems. All right. There was a hand, and now the hand is gone. I can't remember who was the guy, but if you have a question, you're welcome to ask.
Sir.
Yes.
I can't join the last late. Is the assignment can be done individually?
That's what I said. You can do it individually if you want. If you only want, you don't want anybody with you, you can do it on your own. But you also, you say you can also do it between 1 and 4 guys in a group. I do not want more than 4 guys in a group. But yes, if you do want to do it alone, you're welcome to do it. No problem. Yes, you can. Okay.
Thanks.
Right. But please, people, I need nice reports. Remember, I will save your reports for the Engineering Council, because the Engineering Council will look into your reports. And that's why, please, make sure it is neat, it's nice type. If there is drawings and things, then on the end of the day, do it nicely. Your guys done already, CAD. If there's other ways to draw things, please, people, I need nice reports from you. Otherwise, if you're handing for me a bad report or a report that is not neat, then don't cry if you fail it. But there's another way where you can get good marks and get a very good predicate mark on the end of the day. I always say to the guys, yes, try and get a good predicate mark. If something happened in the exam, then you know if I have only 40 in the exam, I will still pass the subject. I think you do not want to come back next year again for this subject. All right. Any other questions before we start with the first chapter about temperatures?
Sir,
Yes.
let's say we write in a group near the assignment. Like, do we have to bring the peer evaluation form along?
Yeah, yes. For peer, if you're more than one, yes. For peer evaluation form, what you've done in your practicals must be also attached. Yes. Yeah. Yeah.
Okay.
It must be attached if you're more than one guy. Yes. Because that is not a rule from the department or from the university. That is a rule from the engineering council. You want to see how did you work in a group, and did everyone done his part, or did some guys done only 50%, or was never there, and then sometimes what happened, a guy forced you to put on his name. But if you want to work alone, you're welcome to do that as well. All right.
Sir, you mentioned that you're gonna be covering 3 chapters.
Yes.
So I want to know how many class tests are we going to have from your side?
We will have class from now till the day before the exams.
No, like class tests. How many class tests are we going to write?
No. You will have a semester test. What will be covered after we finish with the next chapter, what is energy, we will have a semester test. That means you will have your semester test will be 2 chapters. The chapter about a second moment of area, that chapter will you have only in the exam. But it means that I will see how we will do it. I will try for a small class test to get the other mark for you. Will I try and see if we can have at least about 3 small classes, but that will be online, and that will be a question. What I will say, doing this question for me, I give you maybe a half an hour, then you must email it to me. And then when what's happening, I will mark it, and I send directly inform you what is your mark. The way I will do it, on the end of the day, say the one is count a small class test, one, for example, count, say, for example, let me show you how I will do that. Let me show you quickly how I will do that. Where is that? Can you see this piece of paper? Can you see this piece of paper?
Yes, sir.
Yes, we can.
Right, okay. Now, say, for example, what we will do is we have a small class, your small class test. So you have class test 1, 2, and 3. I will try maybe 3. They can be 4, depend on, we will see how it goes. And say this first test is you get 7 out of 10. The next one you get maybe 10 out of 10. The next one you get maybe 0 out of 20. And the last one of maybe you get 11 out of, say, 30, something like that. And what I will do is, how I will calculate, I will say 50, 60, 70, and I say, okay, you have here 17, 28, and that will be your mark. This is how I will do it for your mark for the small class test. This is the way I will do it. And that is important, people, for you to attend every day, because you will not know when I will ask you. While we are busy with a problem, I can say to you, done this problem now for me and send it. Why not? I can do it. Why not? Because when I finish with a chapter, I can anytime ask you, do for me quickly this problem and send and mail it to me. During the class time, I can also ask you, we have done this and this, quickly done this one for me, because that's also a way for me to see how did you understand the work, or must I go back to certain parts. You know, when now with your new you're the first guys who are working on that Wiley Plus ebooks. There's a lot of videos and things. I have tried there to look into it, what I think you can must look through, but there's also, you know how the work, you can look through other ones as well, but I have put something there for you on detail and say, It's important to look through this, and it can help you. But when we come to certain chapters, I do not find in that chapter what I want there. That's why I will use other slides now out of other textbooks. Well, what we will do now will also explain the same things for you, what is in the Wiley one. But most of your guys also running, what I understand from other groups, running to what we call that YouTube, and you're looking into YouTube for things. Yes, people, that is good. Everywhere where you think it. And remember one thing, I will show you a method how to do things. In the e-book, in your Wiley Plus book, there's also a method. You get a method somewhere else, or somebody else explained to you things. For me, it doesn't matter which method you. If I indicate to you, you must use that method. Yes, otherwise, if you have a method what you use and you get the right answer and your mathematics is 100% correct, I will not mark it wrong. I guarantee you where I'm sitting here today. I will not mark it wrong. I will, if your answer is the same like my answer, I will going to that part and look into it and say, okay, that is the answer. Yes, his mathematics is 100% correct. Get full marks. One other thing, people, if you from today in this class, if you done any calculation, say you must calculate for me a stress, and the answer is 73.69 megapascals. I want to see at least 2 decimals every time after the comma. If you go and say to me, this is 74 megapascals, I will mark it wrong for you, because it's not 74 megapascals. If I ask you today, how old are you? And when you will say to me, I'm 23. No, you're not 23. You may be 22, certain months, certain weeks, certain hours, certain minutes, certain seconds. The reason why I want at least 2, that you will see when we're coming to the last chapter, section moment of areas. If you do not working with 2 decimals after a comma, your answer will be every time wrong. And we will not get the right answer by the end of your problem. That's why, from today, in my class, I don't know what other guys say, you do not round. I will know if the answer is 73.601 megapascal, for example, and you put for me 73.6 megapascals, I know there's a 0. I will still mark it correct, because I know where's the zeros. All right. I hope everyone understands that today, because there's always the guys say, yeah, we understand, and the day after the test, everyone complain because he lose marks, because he's around his answers. You're working for me with at least 2 decimals after the comma. I hope we understand today. Yeah. All right. Okay. Any other questions before I starting with the first part of the work? All right, let me get that slides. I hope you have already run last night through the slides. I hope so. And people, I will jump between the slides and maybe also to my camera as well to draw something for you. Please, if you, I'm not in the D2L now screen. If you have a question, I say always put up your hand, but on the end of the day, I cannot see your hands now. Then you must stop me and ask your question, please. All right. Today, we will start with temperatures. And what we want to do here is, let me continue. Okay, what you already know, I hope so. You know the coefficient of material. The coefficient of material is to tell you the hardness, can I say, of a material, because we were working with steel, copper, aluminium, brass, all type of materials. And when you heat up your material, it will expand. And we will come now to an example as well, what I hope you have done on school, but okay, we'll come now to that. Will expand. And your coefficient will indicate you which material will expand more like the other one. But we will come to that point. You have already, with Prof. Desai, learned how to calculate certain stresses, and you know when it is a tensile or when it's a stress compressed. That is a very, very important part here in this chapter. Then also, Young's modulus, you have already done that, you know that also. And one thing what is important is that your beam must be always in the static equilibrium part before you can work it. That means it must be standing still and things, but we will come to that point. Now, what will be the outcomes? We will start today with a single material, and we want to know if I heat it up and I put it under temperature and where I put a load there, then what will happen? Because what will be the stress then in the material? And then hopefully by tomorrow morning, we will start and say, okay, now I have more than one material. What will happen then? That is where we're working to, but we will first start today only with a single material there. And then you will calculate for me what is the stress in there. I can ask you what is the change in length, all that things what you have already done previously as well. We will come now to a point where we will say we were talking with two different change in length or change over materials, but we will come to that part now. The other thing what I already said to you, we want to see in a change in the temperature. There will be a change in temperature. When you talk about the change in temperature, it means if you are in a room and the temperature inside here is 20 degrees Celsius and I heat the place up to 100, that means my change in temperature is 100 minus that 20 on the end of the day, and that will become out of 80, what I will use because it was already 20. I heat it up to 80. The difference between the two is then 80 degrees if I heat up to 100. All right. The things what is important here is when we come to a point where you have only a material, you have no material in your hand. There is no load on the material. It is on room temperature. That means there's no stress. Nothing will happen with that material. But directly when I start heat up the material or I put another load to it, then there will be a change. And in your case, we were only looking into the change of the length, not in the change of a diameter and all that type of things. But yes, if you have continued with that, like the mechanical guys, then later on we will start looking into that. But now we're only looking into see what is the different changes in the length, what happened with the material. All right. But people, the slides is on D2L. I hope you will work through that also. And then I already said to you, the coefficient is very important. We will talk a lot about now here. All right. Now to come back, what you have done already with Prof. Desai, you have done a mechanical change. What means by mechanical change, you have a load and you put a material there. All right. That means you have, I will try and draw it for you. With Prof. Desai, you have that. You put a load there, a force, and then you have a change. Right, that you have already done. And that is important, people. Listen carefully what I say now. That is what we call mechanical change. Mechanical change, in these problems, we will have two different changes. You will have a mechanical change and you will have a free change. Mechanical change is now when I have a load. I put a load and then there's a change. That means that's my mechanical change. There will be a change in my length. All right, that we know. Okay. Now I have a material, and there is my length of my material, my original length of my material. And I also heat it up. All right. Now, you can go and you can test it, but please do not do it in your mother's oven at home. But I think from school days is, if you can remember at school, you have done in physics experiment. I don't know if you guys have done it, but my school days we have done it. You have a steel ring and you have a copper bowl. Now, when I heat up in the beginning, the copper bowl was going through my steel ring. Now I heat up my copper bowl. It expands till a certain point, depending on the temperature, and that's what we call free change. It expands there, and then on the end of the day, it cannot going through my steel cylinder again. You cannot going through that. That means you have expand because of temperature, and you will only expand to a certain point, and then you will standing still. That I calling free change. Right. Important is we have a mechanical change and we have a free change. Mechanical change is with a load. Free change is with temperature. There's no load, only a temperature. When I heat it up, it means it will change. There will be a change in the temperature, in the material. There will be a change. What you have already know from last time where you are working with mechanical, but this change is a free change. There's no loads here. Here by this part, there's no loads. It's only I heat it up and it changes to a certain point and then it will standing still. All right. That means I have this part now there and things. And now when I cool it down, there will be maybe a change, and that is what we call the change in length. When I cool it down, we're going back sometimes to original length, depend on your stress strain graph, and this is what you have done already. Okay, and that means now for my free change, what will change? The length will change because of my coefficient, and what let it change? The temperature. That means for my free change, this one here, my free change, what will change? The length will change because it will change to a certain point and is standing still because of my coefficient here. And what will let it change? My change in temperature. Right. That means my original length will change. It will change to a certain point because of my coefficient of my material, depending on which material it is, and what will let it change is my temperature. That means you have now two formulas. One formula you have already know. That was this one, the one that you have know from the first part of this subject is my mechanical change. And now the new one for you is the free change part, where I also have a change because of temperature. That means you have a mechanical change and you have a free change. And what we want to know is in this material, when you have a mechanical change and you have a free change, we want to know what will be the stress in there. Because if you're going back to this point here, to this one, there was my first change of my temperature. To go back, to bring it back to my original one, I must use a force to bring it back. Right, because under the temperature, I must use a force to bring it back. That means we want to see what is the stress in that material when my mechanical and my free chains are equal. That's very important. Then from there, I can calculate, but we will come now to that point. All right. The next part is straight to only to show you also what happened with the materials. In 2 dimensions, the first thing what I've said to you again, if the material is only there, there's no stress. That means there's no load, no temperature, it's room temperature, it is there for you. When I heat it up, then you have your free chains to a certain point where my stress is still 0. Because there can only be a stress when you have a mechanical change. That's why I've learned stress is equals to force over area. It means you can have only a stress there if you have a mechanical change. That means if I put a load here, force here, then this will not more 0. Then it will change. All right, remember that. Then it will change. Okay. Now, what I said to you, to bring it back to your original part here, I need a load to bring it back. That's why I have a mechanical change now. Right, and you can see the change in the beginning with are equal. That means I want to see what's the stress in this material when my mechanical change is equals to my free change. Then I can calculate what is the stress. All right. One other thing is what you remember on your stress strain graph. You have first your elastic point. When you go over your elastic point, that means if I put a load here and I bring it back and it did not go till the point, or original point, then it means I have also an allowance. We will work with that also. We have an allowance then on the end of the day if it's not going back to its original length. All right. That means, therefore, we want to have, we know now that is the formula for my free chains, and we have a formula for my mechanical chains. Now, if my mechanical chains is equals to my free chains, that means when my stress will be equals to this. It will be equal to my coefficient times my change in temperature times my Young's modulus. And that is the formula then what I will use to calculate my stress in the material. And people, listen very, very carefully to me today. This formula is only when you have one material, not 2 materials. When you have only one material. You will see tomorrow when we start to combine materials, say it's in series or it's in parallel, then you will see that the formula is totally different. And then you cannot use this formula. This is only when you have one material. All right. Important now is this. When you come to the allowance, then my formula is still my mechanical change is equals to my free change minus the allowance. Now when people ask, how did you get this? Now if you're going back to this part here, can you see it is my free change here minus this part to get this part. Right, which is where we get this one. It is my mechanical change is equal to my free change minus the allowance when you will calculate what is the part. Okay, any questions up to this point? Anybody who want to ask a question? Anybody? Up to this point before we moving to some examples. Anybody? Everyone happy up to this point? People, you're so quiet.
I think we're all happy, thank you, sir.
Okay, right. I know it is easy. Let me continue. All right. I do not want, where's my... All right, can you still see my screen?
Yes,
sir.
sir. We
Okay, good. All right. Now the next people verse things. I do not want to run through it. I want to do other things with you. But this examples is also on D2L. Please work through the things. That's why the slides are there. All right. The first one, and it's very straightforward. You have a diameter of 25 millimeter in steel, and the length is 1 meter. It's clamped by both ends. You say to your temperature in the rod degrees to 60. Calculate the stress in the rod. Right, straightforward is what we have already done. Calculate the stress in the rod. You say to when your ends are fixed, and then you have allowance. All right. And then you also indicate you here what is your coefficient for material and what is Young's modulus for material. All right, for the first one, when you first one we say my mechanical, my free chains are equal. You know that was the formula. I directly sub it in there and I get it. And you can see he put there it is tensile. And the reason for that is because he said to you the temperature decrease to 60 on the end of the day. But tomorrow, I think after tomorrow, you will understand that's much better after tomorrow. Okay, I want to say you have allowance of 0.2. All right, in your formula, straightforward, you put in there and you get your answer. All right, okay, that is straightforward. Okay, what I want now for you is to take for me a piece of paper because you have no questions, and then there's a task for you. I want you quickly to calculate for me what is the answers here in those two conditions. Come, everyone, I want you to check for quickly for me to work out what is. You say to you have a brass spacer, diameter 75 millimeters, its length is 350. Smoothie between the phase of the temperatures is 15. Calculate the compressive force on the spacer at the temperature 50 degrees Celsius when the expansion is completely prevented and when the phase given by 0.15 millimeter. And indicate you what is Young's modulus and your coefficient. I will give you, say, 10 minutes. See if you can get for me the answer, and then I will show you the solution. I want everyone to try. People, please do not sit and wait for me to show you what is the solution. Please.
So do you just mind quickly going back one screen? I just quickly want to write down the formulas.
Right, let me check for you. I get quickly to that point there. So you want me to go one back? You want to see the formulas?
Yes, yeah, please. Yeah.
Well, that
yes.
one. Okay.
Just one on, sorry.
That one.
Yes, that one, yeah, thank you.
Okay, all right.
Sir,
Yes.
can you please show the given information there?
Okay, you want to see the information now? Okay, let me go to information for you. Is it? This one.
Yes, thanks.
Right. But people, you must remember there's more than one way to do it. I will show you now my solution, but there's also a guy who have maybe another way or to do it, and maybe a shorter way. He's doing it. What I try to do is I try and done it a way to try and explain everything clearly to you. Do anybody have for me already an answer for the first part? What is the compressed force? Anybody have maybe an answer for me? Come, people, if you have an answer, please indicate tell us what is your answer. Don't be afraid. I can't start asking call names, but I do not want to do it. Come, quickly. Anybody for the first part? So when the expansion is completely prevented, anybody can tell me what's the force there?
So I'm almost done with that one.
Almost done. Okay. If you're done, tell me. I want to know an answer. And I want to know an answer more than one guy. There's one tip that I can give you in the first part. Remember, your mechanical chains must be equal to your free chains. That I can tell you to help you a little bit. I think that's why one guy asked me to see the formulas.
Sir,
Yes.
I'm gonna give you a try for the first question.
Yes.
With me here, I have 222.66 kilonewton.
Well done. Anybody else have that answer? Now everyone is quiet now.
Two. Sir,
Yes, I listen.
I'm not sure, but I got 222.768.
Okay. More or less correct.
Yes, sir. I got 222.66 kilonewton.
Okay, all right. Right, people, there's the guys get for the first part 222.66 kilonewton and it's compressed because you say it's compressed. Yes, I agree with that. Now, did anybody have already for me an answer for the B part before I show my solution to you? Anybody have a B for the B part? When you say to you, when you have your phase given by 0.15. You also can see that as maybe as a allower, maybe something like that. Anybody have maybe an answer?
Sir. Hello, sir. Sir,
Yes.
I'm gonna give the try for second part, but I'm not so sure about my answer. I have
What's your answer?
318.009 kilonewton.
Okay, tell me now. Okay, right. Tell me one thing. If Let me go back. If you remember where, can you see this? That guy who give him an answer now. Can you see this?
Yes.
All right. Now, if I, where's my pen? If I want a mechanical change to bring that load back to this point here, all right? That was in the first part. You agree? You agree in the first part.
Yes.
Now the second part is I put a load here. I bring it back only till this point here. Now, do you think that the first force, let me call it force 1, and let me call this one force 2. Which one of those two forces will be the biggest one? Which one of those two?
Force 1 will be the biggest. Okay, I see.
Okay, you see, one will be the bigger one. That means somewhere you make a mistake. But that means your force in this case with your allowance will be smaller, like the other one. Right. Check again. Somewhere you make a mistake. I think your approach is 100% correct, but somewhere you make a mistake. I come people in. Yeah, what's your answer?
I got 170.4 kilonewton.
170.
Yes.
Okay. There's a 170 people. What is smaller as the A1? Anybody else with an answer? Before I show you the results. Come people, we cannot only have there's two guys in this class. When I check,
Hello, sir.
Yes.
I also got 170.4 kilonewtons.
Did you and the other guys sit together?
No, well, it's actually 403. So
Okay, I don't know how did you guys get that, but okay. Anybody else for me? That is 3 answers now. Anybody else? What I can say to you, none of that answers is yet correct.
So I'm gonna give it a try at 522 newtons.
522 Newton. No, put that for me in kilonewtons.
0.522.
No. Okay. Somewhere you make a mistake, but you are nearly by the answer. Somewhere you make a mistake. Somewhere you make a mistake. With your comma. Okay, let me show you. For the other guys who didn't done it and want to copy. Thank you for the guys who try his best. All right, let me get back to mine and I will change my screen. We can discuss it. All right, can you see my screen? People, can you see my screen?
Yes.
Right, I maybe done it in a long way to explain it to you. First, what I have done, I know by the first part A, if that my mechanical change and my free change will be equal, must be equal. That's why I quickly calculate my free change, and it was 0.196 millimeters, and I know that it must be equal. Well, that was the formula what I have done previously, but then I also indicated we know that stress L over E is also FL over AE. When I done the calculations and I get the answer, what most of the guys get there was 2222.66 kilonewton, and it is compressed. Important is to indicate what is it. People, okay, he ask you that, but it's better to indicate it. When we come to the second part, the one guy was with a 52 was right somewhere. He make a mistake with his comma. The second part said to me that I have that face part there of allowance there, when I say my mechanical change minus that 15.15, 150, I get my new change is 0.046 millimeters. Then my formula again, when I calculate it, I get 52.257 kilonewton compressed. Okay. The guy who have an answer of 52.57 newtons, where did you make your mistake?
Sir, I'm not sure. I took a different route than you did. So
Okay.
I'm not completely sure where my mistake was.
Okay, all right. Let me check. Maybe because your answer is right. Only I think you have somewhere you have millimeters and meters and things together there. Only check there. Check if you for your Young's modulus if you put it 10 to the power 9 Young's modulus. Because that's sometimes where your guys make your mistakes, and sometimes where your guys make a mistake is here by from millimeters to meters. All right, people, that was one. Right, I have another one also for you. Let me get that one quickly for you. That will be the last part for today. Let me get quickly the next one for you. Right, there's the next one. All right, there is the next one for you. You say you have a steel link in a machine part is 150 millimeter long and 10 millimeter in diameter. During the operation of a machine, the temperature of a machine is rising by 100 degrees Celsius, and it is found that the length increase by 0.1 millimeter due to the temperature change. Right, people, that's important. Due to the temperature change. Calculate the load in the link due to the temperature change. Right, and again you tell you what's Young's modulus, and again you tell you what is the coefficient. Right, I give you another few minutes because our time is start running out, and see if you can calculate that one for me. What is that force in the link? And I done it a very, very long way, but there's a very, very short way also to do it. Anybody have an answer for me, maybe?
Yes, sir.
Yes, your
I
answer?
got 10. I
You
got
got?
10.47 kilonewton.
Right. Anybody else? People, there was one guy with an answer. Come, our time is running out. I'll give you another 1 or 2 minutes.
Good afternoon, sir.
Yes,
Yes, sir. I got 18 point something kilonewtons.
18, 1-8.
Yes, sir.
Okay, there's another one. We
Yes,
have
sir.
2 different answers now. Anybody else? People, remember, in this case, there is 2 parts. First, he talk about, he say, during the operation of a machine, the temperature of a machine raised by 100. Right, that is one part. Because in that part, there's already a force. Something happened already. Okay? Then after that, the length increased by 0.1 millimeters. Right, there is 2 things. What happened here? Yes.
I'm gonna give it a try. 3.77 kilonewtons.
Right, now we have 3 answers. Anybody else?
18.85 kilonewtons.
Are you ever guys sitting together?
No.
Yes, sir, we are.
You are together. Are you sitting together?
I'm an flesh.
Huh?
I'm gonna read it off.
Oh.
But it's the same president. It's not in the same room.
Yeah, you're in the same room. That's why you get the same wrong answer.
No, we're not in the same room.
The one copy from the other one.
No.
You must do your own work. Do not ask the guy to WhatsApp with an answer for you. You must work it out. I see you must not ask the guy to WhatsApp an answer for you.
Sir?
Yes, all right, people. Anybody else an answer for me before I show you the solution?
Yeah, there it is, but
Okay, what's your answer? Tell us, what's your answer?
18.85 Newton. I'm not so sure of it.
Yeah, you copy from the other guy. You copy from that other
No,
guy.
mine is not kilo. Mine is just Newton. It's
Well, yours is only Newton. Oh, is that only the change? Okay. All right, people, let me quickly, because we must start running out of time. Let me show you the solution. All right. First thing, what happened here, and there's two ways to do it, and I will show you both ways. This is the long way. It's a shorter way as well. We can combine the formula. First thing, what I said to you, there was in the case of a temperature. That means at that stage, your mechanical change and your free change are equal. When you calculate that, you get a load of 18.850 kilonewton. That is for the first part. All right. When you come to the second part, by the second part with your change of 0.1, your mechanical change of 0.1, when you calculate there, you get a 10.472 kilonewtons. When the one minus the other one, because I said to you, you have a allowance there, when you get to your answer, 8.378 kilonewtons. That's your final answer in your link. All right. And if you want to see if my answer is right, if you're going to verse 1, the change, my free change plus my mechanical change. If you put everything in there, you will get the same answer. I can show you. I done it while I'm waiting for you guys. There I done it. And you get 100% the same answer. That is the short way. Because you have a mechanical, you have a free change, and you have a mechanical change. And if you combine that, everyone with this formula, you will get the same answer. Okay. All right, people. And that is important is.
Sorry, sir.
Yes.
May I please just see the last answer that you showed? The one that you wrote down with the pen.
One that I wrote down.
Yes, sir. Thank you, sir. Screenshot are all done. Thank
Come
you, sir.
again? Is it done?
Yeah, I'm saying it's fine.
I saw you taking photos. I can saw it. Don't worry, I can saw it.
Yes, yes. I took a screenshot. Thank you.
I checked the screenshots because on my side it also flash. But okay, people. Yes.
Can you show the up of the meme, like the top part?
That one.
Yeah, thanks, sir.
People, the thing what's important here is, and this one you must not, and this is what you guys every time doing, and I can guarantee you a guy who's not in the class today will do it. This part here is when, and listen carefully to me today, when you have only one material. You will see tomorrow morning, and I hope you will attend the class. I know it's long weekend, but you will see tomorrow morning when we start to combine materials, say it is in series or it's in parallel, everything changes. Now what happening is that you have two materials when the guys going back to those formulas, and that is not right. I will show you tomorrow, because tomorrow morning I think is more important. Today was only the basics. Tomorrow we will combine this again, but with more than one material, with two materials, which is maybe in parallel or maybe it is in series. We will do that tomorrow, and we have two different materials. And now, please, people, in the tutorials, you will see when you open the tutorials, it looks like something like this, and I will show you. Something like this, where I say to you, there is ones what I want you to do out of Wiley Plus, and then there's other 5 problems, what we also are working through, what is old exam questions. That's a little bit different, like what you've done here, but more or less the same thing. And that's why you will see when we have more than one material. But I will show you that everything tomorrow. But please start with the problems already out of the tutorials. I said again to you, if you can do all these 10 problems out of for this chapter, I will guarantee you you will get very good marks, maybe full marks in the exam on this part. Please do that for me and start with the problems for tomorrow. And then we will continue by the part when we say we have more than one material. All right. Is there any other questions before I stop the recording? Any other questions regarding the work from anybody? All right, people, if there's no other questions, enjoy the afternoon. And also, when we will talk tomorrow morning, 8 o'clock, please try to be online by 8 o'clock. I want to start early because tomorrow can take for me an hour and a half only to explain this next part of this chapter. And when you understand this part, then I think you can use this long weekend and also working through these 10 problems and get everything 100% correct. But I'm stopping here now. If there's no other questions, then I will say goodbye and we will talk again tomorrow. See you.
Sure.
Yes.
Yes.